So in this video we're going to take a look at related rates. We know that y is a function of x, so y is dependent upon x. And if x is a function of t, so let's say x is a function of t. T representing time. So for example, we have a balloon where t equals time. And let's say this balloon is expanding. So x is the radius. The radius of the balloon is expanding. So since x is a function of t, y is also a function of t. So as time goes by, this balloon is going to be expanding. We know that the volume will increase as the radius increases when this balloon is expanding. So x is representing the radius. Radius is increasing. Y is the volume. The volume is also increasing. And this can be represented by dx over dt, the rate that the radius is increasing. The rate that the volume is increasing, dy over dt. We can use one of these rates. If we have one, we can find the other rate. So let's try a few problems with this. Say we have a circle whose radius is increasing at 3 centimeters per second. And let's say at one point in time, the radius equals 8. So with this, we know that what we're looking for is the rate of change of the area. So dA over dt. This is what we're looking for, the rate of change of the area. So we know that the area of a circle is equal to pi r squared. So we differentiate this equation. We have dA over dt equals pi 2r times dr over dt. Now from the information given, we know that r is equal to 8 and dr dt is equal to 3. So we plug these in. Pi times 16 times 3. We will find that the rate of change of the area, dA dt, is equal to 48 pi. And this is our final answer. For our next problem, we're going to take a look at a cone. So the radius at the base of the cone is increasing. R is increasing at 2 centimeters per minute. The height of the cone is 9 centimeters. At some point in time, r equals 13. We know that the velocity of a cone is pi r squared h over 3. So we can differentiate this. dy over dt equals pi 2r times dr over dt times h over 3. And now we plug in our values. We get pi times 26 times -2 because yes. we said it's increasing, so it would not be negative 2, times h over 3, so we had 9 over 3 times 3. So we know that dv over dt is equal to negative, or no, just 1/56 pi. And this is going to be our final answer. Let's take a look at another type of problem that you might encounter with related rates. So let's say we have a 13-foot ladder leaning up against the side of a building. So here's our wall, here's our ladder. Okay, we know that this ladder is 13 feet, and let's say it's sliding away and down, away at a rate of 2 meters per second. So this sliding at 2 meters per second, and let's say at some point in time this value x equals b. So we know that dBdt is equal to 2 meters per second and b equals 3. Now, using the Pythagorean theorem, which we will relate the two of these together, a squared plus b squared equals c squared. So we'll differentiate this equation to 2a dA over dt plus 2b dB over dt equals 0. Now we're trying to solve for dA dt, so we'll try to separate it. Now dA over dt is equal to negative b over a dB over dt. So we need to find a in this equation. We know that c equals 13. 13 squared is 169 minus 9 equals 160, the square root of a. So the square root of 160, a is equal to the square root of 160. So we plug this into our equation. We have negative 3 over the square root of 160 times 2 dB dt is equal to 2 meters per second. So our final answer, the rate of change, how fast it is falling down from top to bottom, is negative 6 over the square root of 160. Let's take a look at another problem that you might encounter on this exam. So let's say you are here and there's an airplane flying away from you. This airplane's altitude is 4 miles. So 4 miles. And we want to find how fast this plane is going away from you when the plane is 5 miles away. This plane is moving at 400 miles per hour. So we're going to go back to the Pythagorean theorem equation. Differentiate this to find c squared. So we have 0 plus 2b dB over dt equals to c dc over dt. We are trying to find this right here. So let's separate this. Dc over dt equals b over C times dB over dt. Now we can find C based on the Pythagorean theorem. We know that 25 plus 20 equals, 25 plus 16 equals 41, and the square root of, so C equals the square root of 41. So we have B, which is 5 over the square root of 41 multiplied by 400 miles per hour dB dt, 400, which gives us an answer of 2000 over the square root of 41, and to label this, it will be miles per hour. This is your final solution. The best way to learn these types of problems with the related rates is to practice them. So you can go online and find example problems and just do what we just did and work through them in practice.